Hey everyone, welcome back. It's been over a year since I last posted any system design videos, and I'm thrilled to be back. Over the past 2 years, I've been busy expanding my knowledge and working on large scale applications. I feel more equipped than ever to return and fill in some of the gaps I left before. Today, we're going to talk a little more about the hotel booking system. We're going to recap our system's design and architecture, explore how data flows through the system, design the actual API, and discuss some key optimizations that enhance user experience and performance. Here's a little recap of the overall design. A lot of you have said this is not a front end system design. I kind of agree, but a lot of times the interview doesn't have a standardized answer. It is trying to evaluate a candidate's problem solving skills. And if you are able to demonstrate strong understanding of certain topics, I think that's still a plus. And in today's video, we will steer the conversation to a more front end focused discussion. We will be mostly discussing the search UI, the booking page, and hotel detail page. Performance and SEO could be quite important for a booking site, similar to a e-commerce website. For the overall design, I think we could leverage server rendering and combine it with React hydration and client-side navigation. I will cover more of its benefits while discussing performance. Let's start with an overview of the main areas we'll cover today. First, we will talk about the expected data format for various APIs. Our main focus here is on three primary flows. Number one, search UI and results. How users search for properties and view the results. Secondly, hotel detail page. What happens when a user selects a hotel to see more detailed information? Last but not the least, the booking process, which leads to a reservation. We will then discuss different pagination approaches, mainly offset-based pagination versus cursor-based pagination. In the next video, we will cover various optimizations, including internationalization, which means catering to a global audience by supporting multiple languages and currencies, SEO, which means enhancing our site's visibility on search engines. Plus, the use of SSR itself plays a vital role in boosting SEO performance and user experience. Now, let's move on to data schema and API design, starting with our search page. The search functionality is built around a simple HTTP GET endpoint. It will take multiple query parameters. These allow us to customize a search based on the user's needs. For example, a typical search URL might look like this. Let's break down the search parameters. Here's the list of basic search parameters. They are all pretty straightforward. The room type and amenities are basically an array of string. We have some sorting options based on price, reviews, etc. One thing I'd like to call out is Airbnb allows you to pick a city directly. There are multiple ways of representing the actual data. One is use a bounding box of 2 points latitude and longitude. Another way is to pick the center and define a radius. Either should be fine. And if user just types in a city, then there will be a backend service that reads the string and somehow translates that into a bounding box eventually. And here is an example of what the JSON response from the search endpoint might look like. Next, I want to cover a little bit about the pagination on the results page. There are basically two ways of implementing pagination: cursor-based pagination and offset-based pagination. The offset-based pagination basically leverages the offset and limit commands in SQL to paginate data. The pros include: 1. It allows the clients to view the total number of pages. 2. It allows clients to jump to a specific page by passing the page number. The cons include: firstly, result is inconsistent. If an item in a previous page is deleted, data will shift forward, causing some results to be skipped. If an item in a previous page is added, data will shift backwards, causing some results to be duplicated. Secondly, offset inefficiency. Offset-based pagination doesn't scale well with a large data set because the database looks up for offset plus limit number of records before discarding the unwanted ones and returning the remaining. Hence, the query time increases drastically as the offset increases. The cursor-based pagination utilizes a pointer that refers to a specific database record. The pros include: First stable pagination window. Since we are fetching from a stable reference point, the addition or deletion of record will not affect the pagination window. 2. It scales well with large datasets since the cursor is unique and indexed. The database jumps directly to the record without iterating through the unwanted data, hence making it more efficient. The cons include: 1. The cursor-based pagination doesn't allow clients to jump to a specific page. 2. The cursor must come from a unique and sequential column, for example, timestamp. Otherwise, some data will be skipped. 3. It has limited sort features. If the requirement is to sort based on a non-unique column, for example, first name, it will be challenging. To implement using cursor pagination, we sometimes need to concatenate multiple columns to get a unique key, which leads to a bigger time complexity. Whether to use cursor-based pagination or offset-based pagination, we can still use the encoded cursor. The encoded cursor basically suggests returning an encoded base 64 string regardless of the underlying pagination solution. This makes our API unified. When using offset pagination, we encode the page number and total page into a base 64 string and return it as a cursor to the clients. A sample response look like this. Similarly, we can encode the cursor in the cursor pagination into a base 64 string before returning it to the clients, and a sample response look like this. Another use case where you want to use cursor-based pagination is when there is infinite scrolling, like a Facebook or Instagram feed page. If you want the ability to jump to a specific page or know the total page number, then offset-based pagination is the one. Next, let's go over the hotel detail page. The API is a pretty simple HTTP GET API, and we've already kind of seen the response, similar to what we got for the search results. Last but not the least, let's cover the API for hotel reservation page. We are going to use a HTTP post request since we will be making edits to our resources. It is a pretty standard post request with all the params for filtering. One thing to mention, usually when reserving a room, we just put a card on profile, so we actually are just going to take the last 4 digits of the credit card to avoid storing sensitive information. You can see the sample parameters and response. That's it for today. I'm making the next video about the optimizations we can do, and it will be a handful. Stay tuned.